So I need you to download the lecture notes, but not now, because I'm going to do the presentation here. Maybe after this, you just have a look at it and try and read it, okay? Because the final lecture is more towards understanding rather than calculation. Because in the previous lectures, I've been explaining about the work done and whatnot. So you have to do calculations, especially on determining the electric field. But today will be more descriptive. So for those who don't prefer doing the mathematics, so this is the best lecture. So we are going to continue with 4 topics: permittivity, capacitance, dielectric, and capacitor connections. So you need to understand the 4 concepts here. So the first one is permittivity. So when we talk about permittivity, it is basically the constant that you have encountered before. But the thing is, you never understand the meaning of epsilon naught. Am I right? I've introduced you epsilon naught, especially the value of epsilon naught is 8.85 times to the 10 to the minus 12 farads per meter. So meaning to say, I've just introduced you naively without explaining the meaning of that. So meaning to say, permittivity. So the word permittivity means that you have a material or you have a medium. So because vacuum is a medium, the air is the medium. Let's say if you have a glass, a block of glass, and then you have the electric field penetrating the glass. So permittivity is about how well does the material allows the electric field to penetrate. The higher the permittivity, then the higher the ability for the electric field to penetrate. Okay? I hope you get the idea. Materials with a high permittivity constant are good at storing electrical charge. So I'm going to introduce you about the capacitor after this. So capacitor is just like the battery, the AAA battery, okay? So you have a 1.5 volt battery. It's basically the same, but instead of using the chemical energy, you are using the electric field to store the energy, okay? So that is the idea. Okay, a capacitor is just like a battery, okay? A capacitor is just like a battery, but it is a short-lived battery, okay? But for a real battery, I mean, the battery that you bought, AAA battery, I mean, it can provide you with the electric current within a given time period, for example, in 1 week or 1 month. But a capacitor, maybe it can give you the electric current for 1 second or 2 seconds or even 1 microsecond, which so I mean the period of the discharge will be depending on the property of the capacitor itself in terms of capacitance. Okay, so I'll talk about capacitance after this. So you just think your capacitor as a battery. So normally we have 2 plates here. So if we draw this in 2 dimension, we will have the first plate, and then we have another plate like that. And then we connect this guy with another end of the battery, okay? And then we connect another guy to the other end of the battery. The reason why we have the battery here is not because that we want to compare with the battery. We want to have a potential difference here, okay? So that we can bring the negative charge and the positive charge towards the respective plates. So here we have the positive from the battery. So we will have more positively charged here. And then it will be more negatively charged here. Okay? So I hope you get the idea. If we refer to the notes here, okay? So if you look at here, actually we have a battery here. So the positive terminal is connected to one plate, and then the negative terminal is connected to another plate. So we have positive and negative, okay? So meaning to say, the electrons from the battery will be accumulated here. Do you know the reason why it is accumulated here? Because the negative electrons, they dislike the negative terminal. So they will be driven towards the plate here. The potential here is negative, okay? So of course, the electrons, they don't prefer to stay here, and then they move towards the plate, and then they will accumulate at the plate. So I hope you get the idea. Same goes to the positive terminal. So we have the positive charges moving towards this plate, because the positive charges, they don't prefer to sit next to the positive terminal because they repel to each other. So I hope you get the intuition. Okay, now instead of using the diagram here, I'm going to use the diagram here. So we have the battery over here. This is the negative terminal, positive terminal. Then I have my wire being connected to one plate. So now the plate here is positively charged and another plate here is negatively charged. So due to that, it creates the electric fields, no? Because we have the positively charged plate and the negatively charged plate. So the electric field will be towards this direction, from positive towards the negative terminal. So now, since we have the accumulation of the positive and the negative charges, so positive will accumulate at this plate, and then the negative charge will accumulate at this plate, they will attract to each other. Positive will prefer to go towards the towards the negative charge, or on the other hand, or the electron prefers moving towards the positively charged plate. I mean, the electrons here they get attracted with the positive plate here, so they got attracted, so they remain staying there forever. Do you see what I mean? Let's say if I previously we have the battery over here. Let's say if we charge the capacitor. So we put the battery, we charge the capacitor. Now all of the charges have already been accumulated at their respective plates. So positive over here, negative over here. Let's say if I remove the battery now. So here we have an open circuit. So the charges will remain over there. It remains at their respective plates. Okay, the charges will remain at their respective plates. So because there is no connection here, so the positive charge cannot use this route. So as you can see, the electrons will always prefer going towards the positive plate. So instead of using this direction, we can also it can also use this direction. But here we have an open circuit, so there is no way of getting towards the positive plates. But rather than going along the direction here, okay. So the blue line here is the blue arrow here is not the electric field. Okay, it is that possible direction of electrons, so that it can gets attracted with the positive charge, with the positive plate here. So as you can see, you are actually storing the energy in the capacitor. So regardless whether the battery is there or not, they will always be accumulated here. Now, just now I placed my battery over here. What happened if I place an LED over here? I mean a bulb or whatever. So meaning to say, we can consider this as a ground. Okay, so it is connected. So instead of moving towards, so we have the electrons here. Okay, I repeat again here. Previously we have the battery. So we put the battery, we connect the battery with the capacitor so that we charge the capacitor. Now suppose that the capacitor has been charged. So most electrons have been accumulated here. And then the electrons here are attracted towards the positive plate here. And then previously I've removed the battery, right? So it is an open circuit. So there is no route for the electrons moving from the negative plates towards the positive plates along this direction, because it is there is no route, no? Because there is no connection. Let's say now if I place my my bulb over here. Let's say I have a bulb over here. So I have a connection here. Then my electron will be drawn from here towards this direction, because it gets attracted towards the positive plate. Instead of moving towards this direction, it is much more easier for the electron to move from this direction to this from this point to this point along this direction, because we have a conductor here and then we have nothing at the center here. So the electron cannot flow through unless it can do so. Let's say because I've mentioned before, the electron will move from here to here instead of moving towards this direction. It is not that I'm saying it is not possible for the electron to move towards this direction. It is just that because we have nothing in between the two plates. Okay. So the electron cannot flow. Okay, the electrons cannot flow through the empty space. Okay, let's say if the electric field is too strong, such that the electrons can jump from one plate to another. So it means that we have the capacitor breakdown. Okay, if the electric field is strong enough, let's say if we connect the terminals here, instead of connecting it with the battery, we connect it to a power source which is very high in voltage. Let's say if you have 3000 volts or 3 kilovolts and something like that, then basically you are creating a large electric field here. I mean, a high magnitude, an electric field with high magnitude between the plates. So it is possible for the electrons to jump from one plate to another because the electric field is too strong. The attraction is too strong. So regardless whether we have a conductor at the center here or not, even though we have an empty space, because of the electric field is too strong, then the electrons will jump. So that will cause the spark between the plates. You know, have you seen the spark between the plates? Let's say when you are about to connect one 3-pin to the plug, and then sometimes you heard the spark. So it means that the electrons are jumping from one plate to another. Okay, because the electric field is too strong. So that's the idea. So now when you replace this with the bulb, so meaning to say the electrons are flowing from here, going through the bulb. So the bulb will lights up. Okay. So depending on the number of charges here, over time, there will be lesser and lesser electrons flowing through because we have consumed the electrons. The number of electrons accumulating at this plate is reducing, you know, because we have connected to the bulb and then the bulb is connected towards the positive side. So over time, the number of electrons will be decreasing. Okay. So if you have a capacitor with a small capacity, okay, with a small capacity, so meaning to say less number of electrons in the capacitor. So let's say if we have a capacitor with a lesser amount of electrons accumulated in the capacitor, then the bulb will light up just in a short while. Just in a short while. Okay, maybe in a matter of 1 second, 2 seconds. Okay, you will feel some discharge. So back to, so I've explained this. So I've explained the permittivity. So now let's have a look at the equation for a capacitor. So the capacitance is a measure of how, I mean, it is a measure of the ability for that capacitor to store electrons. That's it. If that capacitor is able to store more electrons, then its capacitance is higher. So the word capacitance, what is your capacity? Okay, I have a high capacity. So let's say if I am if I am intelligent guy, so my capacity is higher compared to the guy which is not intelligent, because I can store more information in my brain. So more information in my brain, so my brain capacity is more. So that is the idea. So if you have a capacitor with a higher capacitance, it means that it is able to store more charge. Okay, the equation here is it tells you how to get the value of capacitance. Let's say if you have a capacitor, this is your capacitor, okay? This is a symbol for a capacitor. And then you measure the voltage using a voltmeter over here, and then you are connecting your capacitor to a battery. So you measure the voltage across the capacitor. And then you know the current. So basically, once you know the current, you should be able to know the charge as well. So you know the charge across the capacitor. So the charge across the capacitor is Q, and then the voltage across the capacitor is V. Okay, Q over V is given by the capacitance. So if you want to measure the capacitance of a capacitor, you connect it to a battery, and then you measure the voltage across the capacitor, and then you measure the charge across the capacitor as well. So you will be able to know the value of C. But the value of C is not dependent on the volt. So you don't confuse yourself. Yeah, I need to repeat this. You don't confuse yourself. So maybe you might say if the voltage is increased, then the capacitance is higher. No, it's not that. Capacitance is the property of that capacitor itself. It has nothing to do with the voltage here. If you put more batteries, then the voltage will be higher. Okay? But the Q and V here, the purpose of having Q and V here is just to measure the capacitance. But this is not the definition, okay? You have to be able to differentiate between an equation and a definition. So if I have a definition, normally I'll use the triple line here. This is the definition. But if we have the equation, so we have C equals to Q over V, it doesn't mean that if V increase, then capacitance will be lower. Capacitance is a constant. It is a constant, okay? It is a property of the capacitor. So that is the idea. So we go back to the slide. So if we rearrange the equation here, we have Q equals to C times V. Okay? The higher the voltage, the higher the if you have a higher voltage, then there is a higher possibility for you to push more charges towards the plates, no? Okay? Or if you have a higher capacitance, meaning to say there is a higher tendency to store the charge, okay? So you have more charges being stored in the capacitor. So the higher the value of C, the higher the value of charge. Okay. So on the other hand, let's say if you have a higher, if you have a capacitor with a higher capacitance, and then let's say V is a constant. Okay, V is a constant. If you have a higher value of C, then you have a higher value of Q. So meaning to say, the current, let's say if you disconnect the capacitance from the battery, and then you connect the capacitor with a bulb, okay, or you just touch the two ends of the capacitor, you will get electrocuted more if you have a higher capacitance. So let's say if I give you an example, so I have a capacitor of a motherboard of a computer, okay. If I have a capacitor of a computer versus a capacitor of the electric generator used by TNB, which one is deadly? Let's say if you touch the two ends of the capacitor. So I have a situation here where I have two capacitors. This is for the computer, and then I have another capacitor, which is a big one for TNB. So both are charged. So which one do you prefer to touch? I prefer to touch this one because this is not deadly. But if I touch this one, the capacitor used by Tenaga Nasional, I mean an electric company in Malaysia, Tenaga Nasional, the capacitor here has a higher value of C, then it is dangerous for you to touch the two ends here because you will get electrocuted. Because the capacity is higher, there will be more electrons in the capacitor. So if you touch the ends, the two ends of the capacitor, then the electrons from the capacitor will be drawn from the capacitor towards you. So meaning to say, it will discharge more electrons compared to the capacitor of a computer over here. So normally the capacitor looks like this, no? Like a cylinder, and then you have two ends like that. So that is the idea, okay? So of course you can always read this. So if I have a parallel plate, so the area of the plate, if you increase the area of the plate, then you are actually increasing the capacitance. So the greater the area of the plate means more electrons can accumulate at the plate. So that is the idea. But if you increase the distance between the two plates, so D is the distance between the two plates, okay? So I have two plates over here, this one and this one, or this one and this one. So if I increase the distance between the two plates, then I am actually decreasing the capacitance, okay? Because if I move them farther away, if I move the two plates farther away, then the electric field will be weaker. Because if you assume Coulomb's law, if you are closer to the source, then the electric field will be stronger. But now, if I take another plate farther from, let's say, if we have the positive plate as the source, so if we take the negative plates farther from the positive plate, then the point here will have a lower electric field. So since you have a lower electric field magnitude, then less electrons will be accumulated at the plate here. So if you bring them closer, then there will be more electrons being drawn from the negative terminal towards the plate over here. So if you increase the value of D, then you are actually reducing the capacitance. And of course, it is also proportional to the permittivity of the medium. I mean, the medium between the two plates. Normally, the basic structure of the capacitor itself will have a vacuum between the two plates. But of course, essentially, we are not having a vacuum. We have the air between them. So the air itself contains the molecules, no? The molecules. So normally we will replace the region between the two plates with the dielectric. A dielectric is a non-conducting materials. It is not like the metals, no? It is just maybe a plastic or maybe a paper or maybe a glass. So it is not conducting, but it will allow the electric field to penetrate through it, okay? It will allow the electric field to penetrate through it. Okay, if the material have a higher permittivity, okay, if the material have a higher permittivity, then the tendency for it to allow the electric field to penetrate through it will be higher. Okay, let's say if we have a material with a lower permittivity, then it will attenuate. So I hope you get the idea of attenuation, okay? It will attenuate the electric field. Just like, you know, your radio connection. Let's say if you are located at, let's say if you are located in the forest, so the signal will be weak. No? So meaning to say the permittivity of the forest is low. But let's say if you are staying in a city, so in a city, the signal connection is good. So you can always listen to music coming from the radio easily. So meaning to say it is easy for you to get the signal. So the permittivity of the region in the city is higher. So it is analogous, okay? So instead of the radio wave, we change this into the electric field. So that is the meaning of permittivity. So basically, normally we have the different materials. Let's say for a plastic is considered as a dielectric because it is not conducting, but it allows the electric field to flow through it, okay? So basically, we express the permittivity of a material or a medium using epsilon sub r multiplied with the epsilon naught. The epsilon naught is the permittivity in the empty space, the one that you have used in your Coulomb's law. So that value, 8.85 times to the 10 of minus 12, if I'm not mistaken. So the constant here is the one that you use in Coulomb's law. So normally we use epsilon sub r as the value of permittivity, the relative permittivity. So the actual permittivity is given by epsilon sub r multiplied with epsilon naught. So that is the idea. So because the equation here, we have epsilon, so we substitute the relative epsilon, the relative permittivity. So here we have epsilon sub r as the relative permittivity, and then epsilon naught as, you know, the permittivity in the vacuum, okay? So you multiply them together. So normally, if you Google the permittivity of a certain material, they will quote you. You will only get the epsilon sub r. So you have to calculate the actual value of epsilon for that particular medium or material. So you just substitute into the equation given in the previous slide. So you have this one. Okay. Now I want to talk about the mechanism. Okay, I want to talk about the mechanism. So I'm going to summarize whatever points on this particular slide. I'm just going to summarize this. Okay, if we consider the two plates again, okay, instead of having a vacuum, let's say if I replace the region at the center here with the plastic, okay, with the plastic. So the plastic should be blue in color. So I have a plastic here. Of course, the plastic will allow the electric field to penetrate. So let's say if this is the positive plate, this is the negative plate. So I'm connecting the negative plate toward the negative terminal of the battery. Negative terminal, this is the positive terminal. So I'm connecting this one to the positive plates. So of course, it will lead to the existence of the electric field towards this direction. Am I right? Because even though the material here is not a conducting material, but it allows the electric field to penetrate through it, okay? So meaning to say the electrons will be accumulating here, but the material will prevent the electron from flowing from this plate towards the positive plate because the material, the dielectric, is not a conducting material. It is not a conducting material. So the electron will never be able to flow through it, okay? But still we have the electric field. The attraction is there. It is like you and your crush sitting in the next door. So meaning to say you are staying here in your room. This is your room. This is you. and then this is your crush. Okay, this is your crush staying there. You can feel the hotness of your crush, because you are staying next to each other. But the thing is, you guys cannot meet with each other because you have the barrier in between. So same goes to this one. You know, the attraction is there, but you cannot move towards that, towards your crush. So same goes to this one. The negative charges always prefer going to the side here, but the dielectric will prevent it from flowing through itself. So the presence of the dielectric will increase. It will increase the capacitance. Because let's say if I have a situation here, if I apply a higher voltage, then the electric field will be stronger. Without the dielectric, the electrons will jump. You know, it will spark, it will jump. But with the dielectric, so it will reduce the possibility of that electron to jump. So at the end of the day, you keep on increasing the voltage here, then more and more electrons will be accumulating here. Okay, so the dielectric here will, I don't know how to say, it will increase the capacitance. So that is the idea. So yeah, now let's move towards the final section, which is easy enough. It is easy enough. So the final section is just like the effective resistance. So if you could remember the equation form here, let's say if I replace my C with R, so it is like the combination of resistors in parallel. Am I right? So I hope you get the idea. But now, instead of having parallel, you have a series, okay? Because the form of equation here, in terms of capacitance, then this is given by the equivalent capacitance. Let's say if you connect the capacitors in series, so you have the equation here. So you know the capacitance of the first capacitor here, and then you know the capacitance of this guy. Then finally, you can always calculate the effective. So I have two capacitors over here. So I can assume this as a combination of two capacitors forming an effective capacitor. So the effective, let's say this is C1. The value of the capacitance of the second capacitor is C sub 2. So I have 1 over C effective equals to 1 over C1 plus 1 over C2. And then I need to solve this so that I can calculate the value of C effective, just like the resistor. But let's say if we move to the next section, if we assemble the capacitors in parallel, then you just have C1 plus C2 plus C3 and so on. It is, if you cannot remember the formula, you can always go back to your resistors, 1 over R1 plus 1 over R2. But instead of parallel, you swap with the serial. Do you see what I mean? So now the form of equation here is exactly the same with resistors in series. But instead of in series, you have a parallel for a system of capacitors. So do you know the reason why you have the summation here? It is because if you imagine this, you have two plates. If you join them together, you will actually form another larger capacitor. Let's say if this is A1 and then this is A2. If you join them together, this guy join with this guy, you have a final larger plate, right? So it is just like a single capacitor with larger plates. Okay, do you see what I mean? So that's why for this particular case, the effective capacitance is C1 plus C2. So yeah, you can always simplify the combination of series and parallel capacitors, just like the resistors that you have learned during your high school. Okay, so exactly the same. But instead of using, if you see this, we have two parallel capacitors, 6 farad and 2 farads. So you just need to add them together, 6 plus 2. So the effective is 6, 7, 8. So here the effective is 8, and then the effective capacitance for the two parallel capacitors over here is 1 plus 3. And then you have 4 and 4. So you have to use the inverse summation formula to obtain the effective. So yeah, that is the idea. Any specific question for this? So I think this is the end of the lecture. So about the capacitor, you just need to understand that in conclusion, yeah? In conclusion, Capacitor is just like a battery. You can always charge. It is a rechargeable battery. It is a rechargeable battery. If you connect the capacitor with a voltage, let's say if you connect the capacitor with a battery, so you are actually charging the capacitor with using the battery. So all the electrons from the battery will flow into the capacitor, and then they will be accumulated in the capacitor. So that is the idea. And then if you replace the battery with a bulb or with a light emitting diode, then the LED will light up because of the electrons from the capacitor will be flowing into the LED. So that is the idea. Okay. I always want to explain to you the deep meaning of the permittivity, but I think it should be enough for you, because if I fill in you with a lot of information, then you will get things confused. Okay, just for your information, yeah, before we end the lecture. So I hope that you don't have any other classes after this. Okay, so let's see. If I have one plate over here, I'm just giving you some extra information. Okay, if this is the negative plate, this is the positive plates. And then I have electrons accumulating over here because this guy is connected with the negative terminal, and here is connected with the positive terminal of the battery. Okay, I have the two plates here, and then the positive charge will be accumulated here. So the electric field will be flowing from positive to the negative. Okay. So imagine just like the balloon, okay, the one that I've demonstrated to you. When you learn about charges. So let's say if I have a positively charged rod over here, I bring this closer. So I'm actually bringing all of the electrons that are distributed evenly in the balloon. I'm attracting the electrons. So more electrons will be accumulated at this side. So another side of the balloon will be positively charged. So same goes to the dielectric material in here. So inside the dielectric material, since we have the positive terminal positive charges accumulated on the plate over here, then I will have more electrons attracted over here. So here these are the electrons of the dielectric, not the electron over here. Okay. So because I have positive charges over here, then it will attract more electrons. So the electron distribution in the dielectric will be accumulated on the left hand side. So the positive charges of the dielectric material will be accumulating on this side. Okay. So initially, you know that you have the electric field from positive plate towards the negative plate. But because of the redistribution of the electrons in the dielectric material, it creates another electric field, intrinsic electric field. So I'm going to denote the intrinsic electric field towards the opposite direction. So the intrinsic electric field will cancel off with the original electric field due to the two plates. Okay, the intrinsic electric field is due to the redistribution of electrons in the dielectric material. So at the end of the day, the electric field will become weaker. So if you have a material with a higher permittivity value, then basically the electric field will be weaker, but the attraction will be higher. Do you get what I mean? The resulting electric field will be lower. Okay, so you don't have to confuse yourself with this. Just for your information. Just for your information. Okay. So the effective electric field will be lower because in a material with a higher permittivity index. But the thing is, the dielectric allows the electric field to penetrate. I'm not saying that a higher permittivity materials will make the electric field stronger. No, I'm not saying that. But basically, a higher permittivity material will have a higher tendency to allow the electric field to penetrate. Okay, but not making the magnitude of the electric field to be higher. It is just a matter of how well do you allow the electric field penetrate through you. Okay, so that is the idea. Do you have any question? So I'm taking more than 10 minutes for you. Okay, so if you got class, you can always leave now. So if you have any question, you can always ask me. Okay.